He's going to talk to you about performance optimization in PHP.
Good morning, everyone. So today I'm going to talk about performance optimization. And first, so I'm Fabien. I'm the founder of Symfony, which is a framework like Laravel. I created Symfony 10 years ago. And Symfony 2 was actually released 5 years ago. I think it was yesterday, 5 years ago. And Symfony is actually, and was actually my first PHP project. Sorry about that. And I made a lot of mistakes. And the first mistake I did is that I thought that PHP was a real language. So the previous language I used was Perl, so, you know. And because of that, I made a lot of assumptions. Those were wrong, and that's why I think that, you know, Laravel is slow. It is slow because it uses a lot of abstractions. It's object-oriented, which means that for any request, you need to load a lot of code, a lot of PHP code. Laravel is slow, and Symfony is slow as well. I think that PHP is slow. PHP is slow, even if, you know, they've talked about PHP 7, and PHP 7 is actually much faster than any other PHP versions. But still, it is slow because, you know, you can't compile PHP to C code or assembler, so it means that you need to interpret the code for every single request. And if you have a look at, you know, a lot of blog posts, everyone is saying that, you know, PHP is slow, too slow, and you need to switch to something else. I think that's not the case, actually. So people think that Laravel, Symfony, Drupal, WordPress, whatever, PHP apps, they are all slow. But I think that most of the time, the frameworks and PHP itself is fast enough. And you don't really care about making PHP or Laravel or Symfony or your web application faster than it is already. And most of the time, when I audit some code, when I have a look at some code, most of the time, it's not, the performance problem does not come from PHP itself, doesn't come from the framework you're using or the app you're using, but it comes from your code. So I would like to say that, you know, most of the time PHP is slow because your code is slow. And there are so many applications out there where a single page takes more than 1 or 2 seconds to render PHP, and that's awful, really. If you optimize your code the right way, you can render a complex page under 100 milliseconds most of the time. And that's fast enough most of the time. OK, so the question I want to answer today is your application fast enough? You don't want to optimize the performance of your website too much. That would not be really helpful. But how do you know where to start and where to stop? And to do that, you need a profiler. So I'm going to talk about how you can use a profiler with PHP. So, and when we're talking about performance optimization, you need to know what we are talking about. And profiling is a way to actually measure what's going on in your code to give you odd numbers you can reason about instead of, you know, trying to shoot in the dark, trying to optimize the code because you think that you understand what's going on behind the scenes. Most of the time, as human beings, we are not very good at understanding how a computer works. So never, ever start a performance optimization session without numbers. But before diving into performance optimization, I want to give you some numbers. 40% of web users leave a website that takes more than 3 seconds to load. And when I'm talking about 3 seconds, I'm talking about the time it takes for a page to be rendered in the browser. So it's the all time it takes for PHP to actually process the page, the time it takes for the network to move the bits around, and then for the browser to actually display the website. It's like, and most of the time, if they leave the website, that's forever, which means that if your web applications are not fast enough, you're going to lose both customers and revenue. So that's why performance optimization is key to success. If you go to a restaurant, you don't want to wait too much, right? If you are waiting too much, you're going to leave and you won't come back. And that's almost the same with a website or a mobile application. And I think that's even worse for mobile apps. And big companies demonstrated over and over again that there is a direct correlation between the performance of a web app and the revenue of the website. So Amazon.com, at some point they were able to shave 100 milliseconds out of the page load. And when they improved the page load by 100 milliseconds, they were able to increase the revenue by 1%. And that's huge. Just 100 milliseconds means 1% more in terms of revenue. And the same goes for Firefox. So Firefox, you don't buy anything. So the metric is a bit different here. And on the download page, so when you decide to actually download Firefox, and you know it's going to take some time to actually download the software, it's going to take a minute, perhaps 2 minutes to download Firefox, and then it probably takes something like 10 minutes to install and execute the software. But even though just optimizing the front end by 2 seconds, 2 seconds might seem huge, but for front end that's not that big, they were able to increase the number of downloads by 15%. So again, you need to optimize your web apps because it means more business, more engagement, really. So how do you make sure that your app is actually fast enough? And the thing is, if your web app is not fast enough, that's a bug. It's a bug like any other bug. If your checkout page is broken, you're going to have less revenue. If your checkout page works but is really slow because you have hundreds of SQL statements executed for the page, you're going to lose customers as well. And you know that solving issues in production costs a lot more than trying to solve the same issues in the development environment. So you need to take care of performance before deploying the code to production. And that's the big difference between APMs, monitoring tools like New Relic. How many of you are actually using New Relic on production? Okay, quite a few. I think it's too late. New Relic is able to tell you that something is getting slower in production, which means that a user actually experiences the slowdown. It is much better if you can actually fix this issue before you actually deploy the code to production. Okay, so before starting to talk about how to use a profiler, you can do several things to actually optimize your performance without doing anything in your code. The first one is upgrading to PHP 7. Very easy to achieve, mostly compatible with PHP 5.6. That's the first thing you can do. HTTP 2, not really to optimize the performance of PHP, but to optimize the experience for the end user. And using an HTTP cache is actually also something that you can do very easily. So I'm mentioning Varnish, but there are other possibilities here. And as Laravel is actually using HTTP kernel and HTTP foundation, you have everything you need to actually set HTTP cache headers in your code so that if you are installing a reverse proxy like Varnish, you can actually bypass PHP most of the time. But of course, at some point, you're going to have some dynamic calls like a search engine, logged in users, and of course also at some point you need to warm up the cache, so which means that some of your users are going to eat PHP. But that's the first things that you need to do, HTTP caching, PHP 7. So performance is important because we don't have infinite resources on our servers. Of course, if you have infinite resources, if you don't care about the cost, you can add more servers. But the reality is much different. You have a limited amount of resources. So I'm talking about the CPU, the network, the memory, the disk, etc. So trying to optimize your code is actually trying to optimize the resources that you have, trying to lower the memory, the network latency, and things like that. So adding servers is one solution. I think it's not the right one, especially because adding more servers means adding more complexity. That makes sense if you have a big website with a lot of traffic, but for smaller websites, if you can't keep everything on one server, it is much easier to actually manage and reason about. And having only one machine is not really possible anymore nowadays because you have microservices. You are probably using some kind of containers to host your application, or at least you are thinking about migrating to containers, which means that at some point you're going to have more than one machines. But then each container is actually smaller than a regular server, which means that optimization is even more important in this case. So improving performance is actually all about optimizing resource usage. So the performance of a web app or a mobile app depends on, or an HTTP app really, if you have an API or web services, depends on the time it takes for PHP to actually generate the HTTP response for an HTTP request. It depends on the time it takes for the data to actually be retrieved from the server by the client, and then the time it takes for the browser, the client in general, to display the page. But today I'm only going to talk about the back end, so how you can optimize your PHP code, your Laravel app. There are many tools for front-end performance optimization, but I won't have time to talk about those, so you can have a look anywhere on the internet. There are so many videos and blog posts about that. So to be able to optimize your code, you need to have some numbers, which means that you need to get useful information about how your code behaves at runtime. So you need to instrument the code to collect data about it. So you need to collect the memory consumption, the number of times some function calls are actually called, the duration of those executions, and things like that. To be able to do that, you need a PHP extension, right? You need to hook into the PHP engine to collect useful data. But the first step is probably you can probably start by using microtime. How many of you have already used microtime trying to optimize some code? Yeah. It kind of works. The problem with microtime is that it can tell you that it takes 100 milliseconds for PHP to execute this snippet of code, but it can't tell you why it takes so much time and how you can actually optimize the snippet of code. So then you need to guess how you can optimize the code. But microtime introduces one fundamental notion for performance optimization, and that's the wall clock time. Because of course, when we talk about performance, time is probably the first dimension you can think of. The time it takes for a page to be rendered, the time it takes for the browser to render the page, the time it takes for the user to actually see a result in the browser. So time is probably the most interesting dimension you need to look at when trying to optimize the performance of an app. And the wall clock time is actually the first thing you need to understand. So the wall clock time for a function call is the measure of the real time it takes for PHP to execute the code, which means the difference between the time at which PHP entered a function, here the foo function, for instance, and the time at which PHP left the function, right? So here, the wall clock time for the foo call is actually the time it takes for PHP to execute bar and echo foo. It's also called the inclusive time because it includes the wall clock time for the function call, including the inclusive time of all the children. So if you take a look here, you can see that foo, the foo function actually calls bar, and the inclusive time includes the time it takes for bar to execute. The inclusive time allows you to find the critical path of an app. So if you follow the functions with the highest inclusive time, you will go down the critical path. And this is where you need to look at when trying to assess your application performance. And of course, if we have this notion of an inclusive time, we also have the notion of an exclusive time. This is the exact same thing as before, except that now we are excluding all the function calls within foo. So here the exclusive time for foo excludes the time it takes for bar to execute. And this is a great way to actually find functions that consume most of the time by themselves. So that's probably the ones you want to optimize first. But time comes in several flavors, really. It's a bunch of different things. And one of them is input-output I/O. So basically, we can say that the wall clock time is made of two parts. The first one is the CPU time. The CPU time is the amount of time for which the CPU was used to actually process instruction, computation. The I/O time is the time during which the CPU actually waits for some kind of input-output. And those operations can be tied to the network or the disk. So splitting the I/O time is a great way to actually spot functions where some intensive I/O activities take place. And because, of course, you don't optimize the code the same way if your code is CPU intensive, or if you are doing a lot of database calls or HTTP calls or whatever, or if you include a lot of big files, in which case you're going to have a lot of disk I/O. And also keep in mind that, so that's a simplification, because of course you also have some non-significant activities, I/O activities going on, like memory accesses, but most of the time those are not significant in your code. So when we're talking about performance optimization, you need to have a look at a lot of different dimensions to understand what's going on and how you can make your code better. And the main visualization for that is what we call a core graph. And I'm going to show you some core graphs afterwards. And again, the backend profiling does not measure network latency, assets downloading, browser rendering, JavaScript runtime, and things like that. Okay, so I've talked about time a lot, and I think that's perhaps because that's the most interesting dimension and the easiest one to understand. But you need to keep in mind that time is just a consequence of something else. So when you're trying to optimize your code, you don't really care about time. You need to care about the root cause, and time is just a consequence. So if a page takes 10 seconds to render, and if you can count the number of SQL statements and you see that there are 100 SQL statements executed for a page, you probably need to lower the number of SQL queries. And if you are able to do that, the time it takes for the page to be rendered is going to be much lower. So another notion that is really important is the notion of metrics. And a metric is actually something that you can measure that is not the time. And most of the time, this is the number of function calls for a specific area in your code. It can be HTTP queries, SQL queries, whether the debug mode is enabled or not, whether you enable the cache in production or you forgot to actually enable the cache in production and things like that. And to be able to be sure that you actually did the right thing, because sometimes you say, okay, cache is enabled, but in reality, you messed up, and in production, it's not enabled. So you need something, and a profiler is exactly the tool you need to be able to do that. And it works in development, testing, staging, and production, of course. Okay, so I wanted to do a demonstration at this point. I'm going to try to do one. If you can stop doing anything with the Wi-Fi access, I think it's going to help a lot. Okay, so this is a PHP app, a very simple one. So basically, this is a GitHub clone, read-only GitHub clone. So this is a PHP app. I want to optimize this page. I have no idea of what the code is doing. And I'm going to use Blackfire for that. So Blackfire is a profiler. There are several ones in PHP. I'm going to talk about the other ones afterwards. So Blackfire, the great thing about Blackfire is that you can install that in production, and by default, there is no overhead. So by default, there is no performance penalty by just having it enabled, which means that you need to trigger the profiler somehow. And one way to do that is via the Chrome extension. So we have a small extension here. I'm going to click here on profile, and it works. Cool. So as you can see, it takes some time because we are taking several samples of the same page so that we can average all the results to give you more accurate results. It includes, so by default, when clicking on this profile button, I'm actually profiling this page, the current page in the browser. So you can see that we have some numbers at the top of the screen. So this is the summary of the profile. So this is the world clock time, 190 milliseconds. This is the I/O time, the CPU time, the memory, the network activity, the number of HTTP requests, the number of SQL statements that were executed for this page. So this is a broad summary. But now, if we want to understand what's going on, we can click here on View Profile. And then you have more information about what's going on in your code. So on the left side of the screen, you can see all the function calls for this page. And then we have the call graph. So the call graph here, if I zoom in here, you can see that this is the main entry point. Then we can see that we executed web index.php. You can see that this is a Silex app. We handle the request. Then we have the HTTP kernel. Then we can see that there is a controller here and a bunch of other things. So even if I know nothing about the app now, I know that this is a Silex app, and I can understand that the tree controller is actually the controller used to display this page. Now, you can see two red boxes here, and you can see that those two red boxes are actually the function calls that consume most of the resources. Here, we focus on the wall clock time, but can do the same with memory. For instance, if I click on memory, this is the exact same thing, but now I'm focused on the memory dimension. So those boxes are the function calls that actually consume most of the memory. So going back to the wall clock time here, we can zoom in. So this one is not that interesting because it comes from Silex. So going to the next one, the other one, and we can see that we spent 25% of the time in stream select, which comes from the Symfony process component, which is not that interesting. So I want to know where this is called, and here we can see that it's called 10 times by GitHub client get version. If you have a look at this code, you will see that this get version method is getting the version of Git by running Git version, by executing a subprocess and executing Git version. But within one request, it doesn't make sense to execute that command 10 times because the result is going to be the same, always the same, right? So we can cache this call very easily, right? And it's going to improve the performance, that's for sure. So as you can see, even if I know nothing about this code, I was able to find the main bottleneck really easily, really fast. Then it's then a matter of caching this information, and then, so this is the exact same page, but I have applied the patch, the optimization. I can take another profile, because when you optimize something, you need to actually be sure that you improved the performance, that you actually fixed the bottleneck, right? So let's have a look at the new profile. And if everything works well, we should see that you are using Twitter again. Okay. Okay. And here, it's too small for me, but you can probably see that we have less stream select calls, 48, 46, I'm not sure. And if I have a look here, it should be more important. I can't see the numbers here. 85, right? So we actually optimized the performance of that. There is a specific view that you can use to actually do that much faster. You can compare two different profiles. So I can say, I want to compare, I want to compare this profile with this other profile. And then you can see where we optimize the code. So anything in blue means that the code is actually faster. Anything in red means slower, which is not the case here. And you can see that this one is optimized, which is weird and not that interesting. And if you have a look at stream select, you can see that we have less calls. Yes. OK. So this is a call graph. This is the main tool you need to use to actually understand what's going on behind the scene. I'm going to come back to demo afterwards. Let's come back to the presentation now. OK. So a profiler is the best tool to actually find performance bottlenecks. And this is probably the primary usage of a profiler. But there are many other usages you can find for a profiler. So the first one is understanding and discovering a new code base. So you have this new app you know nothing about. A lot of developers actually work on that app. It is a big app. It's not written with Laravel. It's a Drupal app or a WordPress app. And you need to fix some bugs, or you need to add new features. You don't understand how the code works. You can use a profiler to actually understand which parts of the code are actually executed, and then understanding the critical path of the code base. So it helps understanding how a code base works and be productive faster. The second one, the second usage beside bottleneck finding is checking the configuration and checking that the configuration is actually optimized. I'm talking about the app optimization, if cache is actually enabled, if the extensions are enabled, especially in production. I'm going to talk a bit about one issue I had with the Symfony.com website. So Symfony.com is written with Symfony, of course, and we are using Twig for the templating. And if you know Twig, how many of you are using Twig with Laravel? Okay. So we have a C extension. So one of the key things in Twig is that when you want to display a variable, you say a.b, and dot means that b is actually a method on A or a key on an A array. So there is an abstraction so that web designers, they don't need to understand if A is an object or an array or whatever. A.b works in all cases. It is quite slow because at runtime we need to figure out if A is an object or a string or an array, and then if B is a method and so on. So it takes some time. So we have a C extension that makes the process much faster. And of course, at some point I wanted to enable the C extension, the Twig C extension on Symfony.com. So I install the C extension, and I thought it was working well. And then I used Blackfeather to actually take a profile, and Twig was not, the C extension was not enabled because I forgot to actually enable the extension in php.ini, right? So I made the change and I restarted PHP FPM, and then I took another profile, and the C extension was not enabled, just because I enabled the Twig C extension in the wrong php.ini file. Right? So I fixed that. I restarted PHP FPM. Didn't work. And without a profiler, I would not figure that out easily. It's just not possible. But because I use a profiler, it was really easy to actually understand that something was wrong. And it was wrong because I forgot to actually clear the cache, because we have we compile Twig templates to PHP, and if you don't clear the cache, the C extension cannot be enabled in Twig. So I cleared the cache, and bam, it worked. And I was able to actually check in production that Twig, the C extension, was enabled because I was able to take a profile and verify that it was the case. So validation is also very important when we are talking about performance optimization. Talking about the previous example where we had to add a cache layer to actually make the get version function call much faster. Optimization is most of the time about adding caches. And caches make things faster, but it's also, it adds some complexity to the code. So you need to add cache only if you can back your decision with some numbers. It's not about guessing anymore. I've seen so many people trying to add caches everywhere, just in case, just because it must be faster with a cache. That doesn't make any sense. So you need to have add numbers. You need to prove that here you need a cache layer. It's going to add some complexity, but it's going to actually improve the performance significantly. Using a profiler is also a great way to prevent coding mistakes that could have a great performance impact. And then here I'm talking about how you can avoid performance regressions while developing a new feature. So when you work on a new feature or when you refactor the code, you can take a profile of your code before on your laptop before doing any change. Then you can make some changes. Take a profile after your changes, make a comparison, and be sure that there are no regressions. And last but not least, a profiler can tell you when to stop trying to optimize your code base. When there is nothing specifically slow. Your code might be slow, but everything is slow, or everything is consuming a fair amount of resources. At this point, you need to stop optimizing things. The only option is to actually remove some code from your project. Okay. So optimization is always a trade-off. And that's also why you should stop at some point because, it's a trade-off between speed and complexity. Most of the time, optimizing performance means adding more complexity to the code base. It's not the case if you actually fix some mistakes. If you have some n+1 queries, that's a mistake, so it's not adding complexity. But most of the time, when you optimize a website, it's a trade-off between speed and complexity. It's also a trade-off between the time it takes for you to optimize the code versus the impact for your end users. Does it make sense to actually spend a week to optimize the code, the performance by 1%? Probably not. It's also a trade-off between CPU and memory. If you want to go fast, most of the time it means that you're going to add some caches, and caches means more memory. So keep that in mind. So when using a profiler, you actually collect a lot of data, which means that we know a lot about your code. So we can detect which library, which framework, which CMS you are actually using. And then, based on that, we can do most of the work for you. So without having a look at the core graph, without understanding what's going on in your code, we can detect common problems because we know that you are using Laravel, Drupal, Symfony, Magento, whatever. And so let's come back here. And here you can see that I have a recommendations tab here. And it's quite small. Okay, and here you can see that I have two recommendations. The first one is that you should not run sub-processes in production. And this is exactly the thing I've optimized, right? So here we can see that we actually create 11 sub-processes to be able to display this page, which is probably too much, right? The second one is the other example of I was talking about the Twig C extension. So here we detected that the C extension was not enabled. And as we are in production, you should actually enable the extension. So you can see the expression is quite complex, but basically we are checking that we are not using HHVM because we don't have the C extension for HHVM. We are checking that the PHP version is less than PHP 7 because the C extension is not available for PHP 7, and things like that. So just because we have all the function calls in your code, we are able to detect where you can optimize the code, and we can give you some recommendations on how you can optimize the code without having a look at the function calls. And then we have some documentation where we explain why we think that this is a good idea to actually enable the C extension and how you can do that. Okay. Okay, so that's the recommendations I've just shown you. And we also have performance tests. And performance tests are made of assertions, like your unit test or your integration test. So assertions are a way for you to set your very own expectations on performance for your app. and how you can check code behavior at runtime. So you can define assertions by creating a .blackfire.yaml file in your repository. And an assertion is an acceptance criteria based on the data made available by the profiler. So you can see some examples here on the screen. So the last one here, I'm checking that no emails are sent from the web. So when displaying a page, you should not send emails synchronously. You need to do that asynchronously. So that's what this metric is actually doing. So the metric is emails.send, and then we can assert on the count, and here we want the count to be 0, right? So for each metric, emails.send, you have the count, you have the CPU time, you have the memory usage, the I/O time, et cetera, and you can write assertions on that. Another one is the number of SQL queries, and this is the second one, and then you can assert on the world clock time. But again, as the world clock time is just a consequence, it's always better to actually write assertions on metrics that actually matter for you. So here you can see the first 3 ones. We are asserting on the world clock time, the network output size, and the peak memory. So that's a great way to set your expectation and performance, because, of course, all websites, they don't need to be, they don't need to have the same kind of performance. So on Symfony.com, if a web page takes 2 seconds to load, that's not really a problem. If it was an e-commerce website, we would like to have a much better performance for the checkout page, for instance, or the category page, or the home page, or whatever. And those assertions are run whenever you actually run a profile. So whenever you take a profile on the page, we run all the assertions, we run all the recommendations, so that you have all the information besides the call graph. So in the PHP world, so basically you can use 3 different tools to optimize the performance of your code. The first one is Xdebug. How many of you have already used Xdebug as a profiler? As a profiler? Okay. I think it's not the right tool for the job. Xdebug is great for a lot of things, and it does a lot of things. It's not when it comes to performance, because Xdebug adds a huge overhead on top of your PHP code, which means that it skews the results. It's very difficult to reason about the numbers that given by Xdebug, because the overhead. And there is an overhead with XHprof and Blackfire, but we are trying very hard to lower the overhead so that we don't skew the results too much. So the other one is XHprof. XHprof was open sourced by Facebook. Don't remember when. I think it was 2009 or something like that. It's not maintained anymore because Facebook is not using PHP anymore. They are using HHVM now. So they have the equivalent in HHVM, but XHprof, the PHP profiler, is not maintained anymore. There are some forks, but they are not really maintained. Blackfire is not is another profiler. It was based on XHprof. The first version was based on XHprof. It's not based on XHprof anymore because we found a lot of issues with the code base, so we started from scratch. The overhead is way less than XHprof. And we have more features, so queries and requests, we talked about that. Garbage collection measurements. The great thing about Blackfire and XHprof is the fact that you can use the tools on the command line as well. So if you have daemons or if you have long-running scripts on the command line, you can also use a profiler to optimize them, of course. And so Blackfire being is a profiler that you can use with any PHP version, 5.3 to 7, ZTS, non-ZTS, NTS on Windows, Linux, Mac, FreeBSD, Windows. Transparent instrumentation means that you don't need to change your code, and that's very important. You don't need to change anything in your code to enable Blackfire. We do that under the hood automatically when you actually trigger a profile. So the overhead is really small. We have very accurate timing measurement, much more accurate than XHProf. It's free, it's not open source, but you can use Blackfire like you're using XHProf for free. So now, a profiler is a great way to optimize your code, but nowadays you are probably deploying your code continuously, right? You have a continuous integration somehow with Jenkins or Travis or whatever tools, and you need confidence to be able to do that, which means that you probably have unit tests, and you need to add performance tests as well. And Blackfire can be integrated into your development workflow and with your tools like GitHub and some other ones, so that you can actually manage performance as a feature, right? If a performance issue is a bug, it means that performance is actually a feature like any other feature of a website. Even more if you have an e-commerce website where performance is really key. So a profiler can help you, debug, improve, and validate performance optimization in development. It can help you test and validate the performance of your code whenever you fix a bug or whenever you add a new feature in your continuous integration workflow. And then it lets you decide if you can actually deploy to production to be sure that you don't have any performance regression before deploying to production. It's also very useful in production to be able to monitor and identify problems, understanding what's going on in production, because of course your production infrastructure is very different from your development environment. And the servers are different, the data is very different, so you have a bunch of data that you don't have on your development machine. The network is different, number of customers is different, everything is different, so the performance can be very different in production than it is in development. You might have some kind of performance testing in place nowadays. Some people might do some load testing or benchmarking, and that's great. The only thing is that, the problem is that those tools can test the capacity of your current infrastructure. So a load testing tool can tell you, okay, you can serve 10 requests per second. That's the maximum you can do with your current infrastructure. But it does not tell you why you can't go further than that. You can't have more than 10 requests per second. And that's where a profiler can help. So you can do some kind of load testing, enabling Blackfire, for 10% of the request, and then it can give you some insight about how your code behaves under heavy load, because of course it's going to be different from a single request on your development machine. So automation is key to avoid performance regression, and so I've talked about assertions before, but you can also write scenarios. So scenarios are web pages that you want to check before going to production, and then we have a build system like unit test, really, where whenever you push a new version of the code, you create a pull request on GitHub. We run all the tests to be sure that you don't have any regressions, and then you can see if something is red, it means that you have some assertions that are failing, and then you can have a look at the profile to be sure that to understand what's going on and trying to fix things. Can show you how it works here. Well, it's going to be too big here. Okay, so going back to the dashboard, I'm going to show you symphony.com. So this is all the profiles I've made, but here you can see the build. So I have periodic builds, which means that every 6 hours I run all the tests on the production machine to be sure that everything works fine. And I have some reports, and it tells me what's going on and what's wrong and how I can actually make the code faster. And then you can integrate this with a bunch of tools. You can be notified via email, or you can update the commit status of your pull request with GitHub, GitLab, and so on. Okay, so the goal is, performance is a feature. You need to integrate that into your development workflow like any other tool. Okay. So talking about the Twixy extension again. So I fixed my problem. Symfony.com had the C extension enabled. It worked fine. And at some point, I started to see my builds fail because the Twig extension was not enabled anymore. I did not change anything in the code. I didn't change anything on the servers, but it was not working anymore. And I was wondering why. And just because I received the notification the same day as we made some modification in the way we actually deployed the code, it was very easy to understand why it was broken. It was really easy. The thing is, before, we deployed the code on the same machine as the web server. So the C extension was there, and when we actually warmed up the cache, the C extension was there, which means that everything was using the C extension. And then we migrated to another way of doing things. We were using another machine to actually warm up the cache and then moving the files to the production server. And of course, the C extension was not enabled on this build machine. That's why it was broken. Right? It was an easy fix just because we received the notification the same day, and it was kind of easy to actually spot where the problem was. If we did not have that, if we had this notification, or if we realized the problem 6 months later, it would have been much more complex to understand where the problem was. Okay, so a lot of people make confusion between APMs and profilers, so I wanted to make it clear. So an APM is an application performance monitoring tool like New Relic, for instance. So an APM actually monitors real users and the real user's experience on production servers, and it gives you trends and averages. So it's great for a manager. It's not that great for a developer. It only works on production. You can use that in your development environment, but I think the tool is not the right one for the job. A profiler continuously tests or can continuously test your code performance during the entire life cycle of a project because it's integrated or can be integrated in your developer workflow and with all the tools that you are using on a day-to-day basis. And it also allows to compare two different versions of your code, which is not possible with an APM. The good news is that if you are using Laravel Forge, how many of you are using Laravel Forge? Quite a few, okay. So BlackFerry is available there, which means that it's a matter of browsing to the server details, and then under the monitoring tab, you can enable BlackFerry there really easily. It was not available a few days ago, and Taylor did the change yesterday, so it's available again. It was available a few months ago, and then it's available now. So you can test it out really easily. If you want to learn more about BlackFerry, you can go to the blackferry.io website, we have a lot of documentation. I wrote a book, 24 Days of Blackthor, which explain in greater details the philosophy behind the tool and how you can use the tools to optimize the performance of your Laravel apps. That's all I have for today. Thank you for listening.